So we're going to look at exponential functions here, and a typical one would be a graph of f of x equals 2 to the power x, and it could be any number, but what's significant about an exponential function is the power is a variable. So up there we have a variable x or y, whatever it is, will be in the power. That is the characteristic of an exponential function. Well, first of all, what we might want to do is plot some points here. So let's just do a little t-chart to see what we've got as values. And as with most functions, you can get away with a set of values: -3, -2, -1, 0, 1, 2, and 3. Let's start off with the easy ones first. Let's start off with x equals 0, and 2 to the 0 is going to be 1. Anything to the power 0 is 1. 2 to the 0 equals 1. Next one down is this one. 1 if x equals 1. What's 2 to the 1? Well, that's 2. Next one, if x is 2, 2 squared equals 4. And the last one, 2 cubed equals 8. So we can fill those points in there. If we go the other way, 2 to the -1, well, we just looked at that. That's going to be 1 over 2, 1/2. 2 to the -2 is going to be 1 over 2 squared, which is 1 over 4. And 2 to the -3 will be 1 over 2 cubed, 1 over 8. So when we come to graph this, we need to plot these points, and this graph might be a bit small, but we'll see how we do. So we start with the 0, 1. Well, that's going to be right there. Try and do it as big as we can. That's that point. 1, 2 is going to be there. 2, 4 is going to be up there. And 3, 8 is going to be all the way there. That's fine. Now -1/2 is where it gets a bit complicated. -2 1/4, and what we get is this shape that comes down here. Again, it's a bit difficult to draw with this pen. There. That's not bad, actually. That is the graph of f of x equals 2 to the power x. That shape is familiar with all these powers. So if we did f of x equals 3 to the x, it will be the same shape. It would just have a slightly steeper climb up, and 4 to the x, if it was half to the x, it would come a bit flatter. But we've got some characteristics here. We've actually got an asymptote that exists on this graph. We talked about asymptotes before, but this does indeed have an asymptote along the line y equals 0. And I've done it in a big green line just so it stands out and looks clearer. So I'm going to get that down a bit smaller now to write properly. So that asymptote is y equals 0, like that. Now if we look at the domain of this function, we know that every x value is used to the left because we can substitute any negative number, we can substitute any positive number. So the domain is going to be all reals, all real numbers. The range, slightly different, is going to be, well, let's have a look at what the minimum y value is. Does it get to the green line of 0? No, it doesn't. So therefore 0 is not included, and all these values down here of y, are not used. So therefore, the red graph does not go into the grey area. Therefore, the range is going to be everything outside that grey area, because there's red values up top, and the range will be y greater than 0. And that will be an exponential function.